EE545 Embedded Systems, Embedded Deep Learning, and this is week 12. And let me download the lecture slides first. Here they are, and yes, here they are. You know the password as usual. Desktop, extract. Yes. Okay, here it is. Okay, as promised the previous week, as the previous week. Oh my god, I've put not PDFs. Okay, I'll change it later. Okay, as promised previously, play the slideshow. Okay, so as I promised previous week, this week we are going to talk about neural architecture search. So, guys, what I understand from a graduate course is a graduate course, in my opinion, should be like in the first starting weeks, you work on some advanced fundamentals. I say advanced fundamentals because these are fundamentals which are advanced in a sense that you put them on top of some undergraduate level knowledge of yours. And that was what we've done. Actually, this is an advanced graduate course because this course is put on top of the previous semester's course. And in the first weeks, we have talked about the layers, what a convolutional layer is, what a pooling layer is, what is architectural design. And in the following weeks, using this advanced fundamental of deep learning, convolutional neural networks, we have discussed different co-design architectures like inception nets, and we've talked about quantization, we've talked about binary networks, which is an extreme case of quantization. We've talked about training quantized networks, quantization-aware training. So this was some new knowledge for you over some advanced fundamentals. And in my opinion, towards the end of a graduate course, there should be some future directions, because graduate courses are the last courses that you will ever take. I mean, after these courses, you will never be taking courses. If you're going to continue an academic life, what you're going to do is you're going to find your own way. And finding your own way in an academic career is reading papers. So in my opinion, the last few weeks of a graduate course, especially an advanced graduate course like this, because there are some graduate courses which are not advanced, like, I don't know, if a proper example is linear systems course that it's compulsory to you. It is like an advanced fundamental, totally. But other courses like these ones should give you an idea about the current state of the art of this science. So in the last 2 weeks, this week and the next week, I'll be talking about some future directions. These future directions I hopefully will guide you for the rest of your academic studies if you're interested. I know that some of you are already interested, so I hope it will help you guys. And I hope this will conclude this course, because this is week 12, future directions on neural architecture search. The next week, and at the last week, we'll be holding the project presentations, not necessarily exactly 2 weeks later. We're going to reschedule it, but that's the syllabus of the course. So I tried to make a nice introduction. I don't know if you think that it's a nice introduction, but if I was a student and listening to this course, I would think that it's a nice introduction, because understanding what a graduate course is also a part of an academic life, guys. Okay, so much speaking, so much bullshit, so let's continue. We were talking about this co-design evolution. This was where we left in week 11, guys. So, what we did was, up to now, architectural co-design, guys. We've discussed pruning, channel reduction, removal, and actually some of these, if you remember the previous week, some of these items, just like depth-wise separable convolution, it's an idea, but it corresponds to a specific paper from Google, mobile nets. Another one, shuffle operations, that's an idea. You shuffle the convolutional features among each other, and that idea is being implemented in shuffle nets and as a shuffle net unit by some Chinese AI company. So these ideas become some architectures. But never forget, guys, these are all handcrafted architectures. We designed them. And when humans design them, it is nice because it is transparent. We design them with a perspective. However, real AI, like you guys, because you are the most advanced, intelligent creature that you have ever seen in your lives, as humans we are. We were not designed like this. We were designed totally using a mechanism called evolution. We've become more and more advanced in time. I mean, well, this is of course, a belief matter. Some of you might think that maybe we were designed like this, but at least I do think that if we were designed like this, we were designed to be a part of the evolution, whatever. It's not a philosophy course. I'm just going to pass that on very quickly. But what I'm trying to say is, it is not handcrafted design. Because all of the connections in our brains are different from each other. One of you have some different types of connections in your brain, and my connections in my brain are totally different. There is no human that has the same connections in their brains. Even identical twins have different connections in their brains. Because as we've talked about it the previous week, there's something called pruning in your brains. Well, you have connections from neural cells to neural cells. In the first year, they grow, and in time, you just optimize them by cutting some connections. And even identical twins do it differently. So in terms of an architectural graph, our neural system is unique. So if we happen to be intelligent beings with unique neural connections, then this handcrafted design shouldn't be the best way to achieve a great AI like ours. So guys, the next big thing is finding a machine which will create these connections automatically. So the next big thing, the feature of deep learning is, neural architectural search. A machine that will search for the neural architecture automatically. Deep learning, actually this is, if you look at the big picture, this must be the way. Because before deep learning, and you don't remember those times, I always say this in my lectures and in these video lectures. Well, when I was a PhD student, like 50 years ago, I'm kidding, like 15 years ago, or 20 years ago, well, we have handcraftedly designed features. Okay, let's get the edges, let's get the horizontal edges, let's add them up, let's sum them up. It's a very nice feature, let's publish a paper. That was the way of pattern recognition. Then deep learning came, and within deep learning, using convolutional layers, we had the idea that, well, we don't have to design these features. Deep learning automatically designs features looking at the data. So depending on the data, depending on the task, whether it's a classification or segmentation, whatever it is, the features needed can be computed within the deep learning. Well, that was the idea, getting rid of the handcrafted design. So if the next step is finding a proper architecture, why do it handcraftedly? Why do it in a handcrafted measure? Let's, again, just like we've done in deep learning, which closed the era of handcrafted pattern recognition design, let's find a machine which will close the era of these handcrafted modules, inception module, shuffle nets, whatever. Let's close it, let's finish it. Okay, so let's find deep nets that will create and train features. We have done this, features from data. So why not the same idea, this time applied to co-design? Let's find networks which will create co-design automatically from in a machine. Okay, let's see the big picture first.